Over here, welcome students. Over here we have another question set in the year 1999 by Waec. Calculating joule the binding energy for cobalt. Cobalt has an atomic mass of 59 and number of proton, which is atomic number of 27. Atomic mass of cobalt, which is 59, atomic mass and proton 27, which the mass is really approximately 58.9332 watts. Unified, this symbol, this U means represent unified atomic mass, unified atomic mass unit, which is okay, it's here. The mass of proton is this, the mass of neutron is this. This is electron volts. 1 electron volt is this, and one unified atomic mass unit is 931 mega. This is times 10 power 6, which is same as times 1 million multiplied by your what? Electron volts. So how are we going to do this question? What you do here is I've told you when I discussed the binding energy that the difference between the mass of the product and the reactant is just what makes up the what binding energy. The difference between the product and the reactant. This is the product. What makes us cobalt? What makes up cobalt is what makes up this 59. And this is atomic mass, which I told you that atomic mass it is sum total of what proton and what neutron. And atomic number, I tell you atomic number is same as number of what proton. So what does it mean? Proton is 27, and here we have proton and neutron. So for us to know the number of neutron, what we have to do is what 59 minus what 27. That will give us the number of what neutron. So proton is what 27, then neutron is what 59 minus 27, which gives us what 32. So we have 27 protons inside cobalt, and we have 32 neutrons inside cobalt. And the mass of each proton, mass of proton is this. If one proton is 27, if one proton is 1.00783 unified atomic mass unit, then what will be the mass of 27 protons? All we have to do is what? This multiplied by what? 27. If one mass of neutron is this, what will be the mass of 32 neutron? All we have to do is what? This times what? This. So which gives us what? 27 times 1.00783 U plus 32 times 1.00867 U. These are the things that came together, and when you multiply these two, you have what? 27.21141 plus this, which is 32.27744. And by the time you add them together, this plus this, 1 2 3 4 5, 1 2 3 4 5, okay, 5 8 8 8 4.59 U. So when 27 proton and 32 neutron came together, both of everything has a mass of 59.48885 unified atomic mass. But we are being told that the mass of cobalt is 58.9332. Sorry. Take I said the difference in mass is what constitutes the what binding what energy. So there is not a difference. So that the reactants, which are these, the mass of the reactant is always higher than the mass of the what product. So the difference is what we use to go for what the binding energy. So our difference now is going to be what 59.48884 no 5U minus 58.9332 U. And by the time you subtract this 9332 U, okay? By the time you do the subtraction, 5 minus 0, we have 5. 8 minus 2, you have 6. 8 minus 3, we have 5. 8 minus 3, we have 5. 3 is 4. 40 minus 9, we have 5. 0 point. We have 0.555565 what? U. So this is what we have. The difference in mass of the what? Reactant minus the what? The product. This is what we got. And our answer should be in what? Joules. Our answer is mostly in joules. So we are going to joules. If 1U is 931 mega times 10 power 6 electron volts, then this U will give us what? Watts. So what you now do is now this multiplied by this. Are you getting me? So now do what? 931 times what? 0.55565, which by the time you multiply these two, 931 times that amount, it will give us what? Then mega is, this is 1 million times 10 raised power 6 also. So what you'll be having after typing this into our calculator is 5173 10150 electron watt volts. This is what you'll be having when you multiply them. This is what you have when you multiply. Hope you are with me. Then, and 1 electron volt is 1.6 times 10 power minus 9 joules. That means to convert this to joules, we multiply this by this. So now move further and say 517310150 multiplied by 1.6 times 10 raised power what? Minus 19. This will give us 8.27 696240 624. Let's remove this times 10 raised by what? Minus 11 what? Joules, which approximately is same as what? Our binding energy is approximately 8.228 times 10 raised by minus 11 what? Joules. You can see how easy it is. It's as easy as that. It's very easy. Take note, the proton cobalt is made up of proton, made up of what? 27 proton and 32 neutron. So if 27 proton and 32 neutron, each proton having a mass of this and each neutron having a mass of this, so the total mass of the 27 proton and 32 neutron is 59.48885 unified atomic mass. So if this is the total, and here we have been told that cobalt has a mass of this, and as I said before, by calculating binding energy, we will look at what difference between the mass of the what reactant and the mass of the what product. So the mass of this is higher than this, right? So we get the difference, which is subtraction. And by the time you subtract, you get this. So this is the mass we are working with here. You get me? But since our answer is needed in joules, it's needed, since I'm seeing joules here, so we'll move to these joules. And first of all, we are told that what this U is same as what 931 times 10 power 6, which is this mega electron volt. So convert it to what electron volt, which is 931. This is the mega here, the M. So this is our 0.55565 0.5555565, and this is what we have now in electron volt. And this is the, what is 1 electron volt is in joules. Electron volt is in joules, which is this. We multiply by this, which gives us this, and that is the final answer. Please, as I said earlier, if you haven't subscribed, please subscribe. If anyone who has not subscribed, please let them subscribe. From this point, I'll be moving into what? Energy quantization and wave particle paradox, which is going to be the next topic I'll be what? Treating. Thank you.